Have you ever stopped to ponder the intricate dance of atoms that governs the very essence of our existence? Picture this. Everything around you, from the air you breathe to the ground beneath your feet, is comprised of tiny building blocks known as atoms. But here's where it gets fascinating. Within these minuscule particles lie the secrets of creation, with their cores pulsating with protons and neutrons, while electrons whiz around in a cosmic ballet. Now, consider this. What if we were to mix these elemental building blocks in unexpected ways? What hidden marvels might we uncover when we bring together the likes of hydrogen, oxygen, and sodium? Join me on a journey of discovery as we delve into the captivating world of chemistry, where the simplest of questions can unlock the most extraordinary revelations. Buckle up, because things are about to get positively electrifying. Welcome to our channel, my Paint Explainer. Let's start the video. Valence electrons are the electrons in the outermost energy level of an atom. They are involved in chemical bonding, determining an element's reactivity and the types of bonds it can form with other elements. The periodic table is a tabular arrangement of chemical elements, ordered by their atomic number, electron configuration, and recurring chemical properties. Elements are organized into rows, periods, and columns, groups, based on similarities in their properties, facilitating the understanding of the relationships between different elements and their behavior in chemical reactions. Isotopes are variants of a chemical element that have the same number of protons but different numbers of neutrons in their nuclei, resulting in variations in atomic mass while retaining the same chemical properties. Ions are atoms or molecules that have gained or lost one or more electrons, resulting in a net positive or negative electrical charge, respectively. The periodic table organizes elements by increasing atomic number, grouping them into periods, rows, and groups, columns. Each element is represented by a symbol and accompanied by its atomic number and atomic mass. Elements within the same group share similar chemical properties due to their common number of valence electrons, while those in the same period have the same number of electron shells. Molecules are formed when two or more atoms chemically bond together, either of the same element or different elements, creating a stable structure. Compounds, on the other hand, are substances composed of molecules consisting of atoms of different elements bonded together in fixed ratios, exhibiting unique properties distinct from their constituent elements. The molecular formula represents the exact number of atoms of each element in a molecule. Isomers are molecules with the same molecular formula but different structural arrangements or spatial orientations, leading to distinct chemical properties. Lewis dot structures are diagrams used to represent the bonding and electron arrangement in molecules and ions. In these structures, valenza, electrons of atoms, are represented as dots or lines around the atomic symbol, showing how atoms share or transfer electrons to achieve stable electron configurations. Atoms bond to achieve a more stable electronic configuration, typically by either sharing electrons, covalent bonding, or transferring electrons, ionic bonding, with other atoms. This process allows atoms to attain a full outer electron shell, either by completing it or by emptying it, resulting in a lower overall energy state and increased stability for the bonded atoms. Covalent bonds occur when atoms share electrons to achieve a stable electron configuration. This sharing of electrons creates a bond between the atoms, forming molecules. Covalent bonds are typically found between nonmetal atoms and are characterized by the sharing of one or more pairs of electrons between the bonded atoms. Electronegativity is a measure of an atom's ability to attract electrons towards itself in a chemical bond. It's a fundamental concept in chemistry that helps predict the polarity of bonds and the distribution of electrons in molecules. Atoms with higher electronegativity values tend to attract electrons more strongly, resulting in uneven sharing of electrons in covalent bonds. Ionic bonds form when atoms transfer electrons from one atom to another, resulting in the formation of positively charged ions, cations, and negatively charged ions, anions. These oppositely charged ions attract each other due to electrostatic forces, creating an ionic bond. Compounds formed through ionic bonding are called salts, characterized by their crystalline structure and high melting points. Metallic bonds occur between metal atoms within a metal structure. In these bonds, metal atoms share their outer electrons freely throughout the material's lattice structure, creating a sea of electrons that allows for easy conduction of electricity and heat. This sharing of electrons results in a strong bond, giving metals their characteristic properties such as malleability, ductility, and conductivity.